Right, so this is the chapter 10, the conics and calculus. This is a very different chapters as we introduced a completely new concepts. We're going to start with something we already learned in algebra as the conics that you might have or have not visited. Those are the kind of topics at the end of the college algebra, right? So what's conics? You are probably familiar with some of the type of conics or conic sections. The first one is the circle. Okay, the circle is the one that you are way familiar. Okay, and we do know the equation of the circle as well. If you forget, it should have the form. Let me draw this circle here. Right, so it's gonna have the form something like x minus 3 squared plus y minus 5 squared equals 16. Right, so something like this, where if you look at these standard equations, this is the circle center at the point 3, 5, with the radius is 4. It's 4 squared 16, right? So that one we are familiar with. Now, another type of conics is the parabola. Okay, so we also familiar with parabola. You're gonna have something like y equal to x squared minus 4x plus 6. Okay, this is the general form, and we also have the standard form, looks something like 3 times x minus 2 squared plus 7. In the second form here, you might recall the vertex. This is the parabola with the vertex at 2 and 7. And since this is positive 3, so the parabola open upward. All right. Now let's put it together. We have circle, we have parabola. We actually have two more. It belongs to this type of conic sections called the hyperbola and the ellipse. Okay, the ellipse, as well as the hyperbola. We actually learned hyperbola too, but you might not know the name. The simplest form is y equal 1 over x. And when you graph the y equal 1 over x, you're gonna see it's gonna be two branches like this. Okay, so that is the hyperbola. Hyperbola had two branches. Now, we're gonna collectively combine these four into one name called conic sections. In fact, whether you have a circle or you have the parabola or you have ellipse and hyperbola, right? They actually could be described as the cross sections between a cone and a plane, right? So here is a formal definitions. Each conic section above one of those four you've seen, or simply called conic, can be described as the intersections of a plane and a double nap cone, right? So these are double nap cone, basically the two cones that meets at the kind of the vertex. Okay. Now, the circle, if you take the plane, Okay, so it's like you cut it horizontally. Then you see that the cross sections here is precisely a circle, right? A circle. And if you have a plan that cut it at an angle that's kind of cut the openings of this cone, you got the cross sections right there. It is a what? A parabola, isn't it? See, that's parabola. And if we have an angle there, and then it's not cutting at the openings of the cones out here, you form a ellipse. In the last case, you see there's two branches, actually two hyperbola. Okay, so these are the four cases. Okay, so the name conic section is coined because it intersections of cone and the plane, right? Conic sections, or conics in general, for short. Now, those four, geometrically, that's how we interpret it. Then from the algebraic point of view, those equations actually could be written in this form, the general second degree equations. You see, this equation has at most the second degree, right? X squared here, y squared, some xy term, x term, y term, and constants. So any of these will have the same form, right? So if you look back at what we have up here, and they say, well, how can this be the same as that one? If you take take a look at the parabola, right? So let's say parabola is 2x squared minus 4x plus 6. Okay, so if we have y equal to x squared minus 4x plus 6, then it is that form. Okay, this. Why? Well, think about this. If I rewrite this, let's subtract y on both sides, then you got 0 and 2x squared minus 4x, and then you subtract y and plus 6. Now notice that then the x squared, right? So the a is 2, so that's a capital A. And then the b, there's no xy term, so the b is 0. The c, y squared, I don't have y squared, so the c is 0. And then this is your d, constant d, negative 4x. And then there's an e, here is negative 1y, and the f is 6, right? If you have the standard form like this, of course, it doesn't look quite the same, but if you fold these down, it's going to be similar to this, and we can put in that form. Likewise, when you have the circle, right, x minus 3 squared, and you follow this out, and then rewrite this, and you can put it in the form. Here's another example, right? If you're going to multiply both sides by x, you end up with x times y. Subtract 1, you have xy minus 1 equals 0. You see that belongs to that form as well, where a is 0, no x squared. The b is precisely 1, right? 1xy. The c is 0, d is 0, e is 0, and f is negative 1. All right, now let's get into the detail of each of these conic sections. The two definitions that we have here, either by the cross sections here or by the algebraic, the general equations, are not very useful in identifying the characteristics, some important features of each of these conics. Thus, we're going to use another type of way to determine or define conics. In fact, each of these four could be described as a collection of points. satisfying a certain geometric property. Okay, so what does it mean? Let's look back at the circle first. Circles is in fact it's the easiest one to understand. So what is a circle? Circle is really the set of points that have the same distance from a fixed point. So if I have the fixed point here is 3, 5, right? So let's say I have the point here is 3, 5. Then if you collect all the point that has a distance, say 4. So let's say here 1, 2, 3, 1, 2, 3, 4. Okay, so this point, right, has a distance 4 to the 3, 5. And then you have this point at distance 4 to the point 3, 5. And you have the next point and the next point, right? So if you collect all the points, those that have the same distance, which is 4 in this case, then you end up with a circle. Center at 3, 5 and distance 4. Right, so that's our first conic circle. Now, in general, a circle can be described or defined as the collections of all points x, y that are equidistant from a fixed point h, k. This definition easily produces a standard equation of a circle, right? X minus h squared plus 1 minus k squared equal r squared, right? So again, I can do a quick example here. If you have an equations that have something like x squared minus 1 plus y squared minus 6x plus 3y. Maybe I'll do it easier, not 3y. How about 4y minus 9 minus 9 0. Okay, so we see again, this is the general equations like it belongs to that form. But if I ask you to identify, okay, what is the center, what's the radius of the circle, then you cannot tell from here. And this is where well, all the standard form, this is the standard form here, standard equations come from. If you put it in that form, I can tell the HK here is the center, the R is the radius. So to do that, you're gonna have to complete the square. I'm gonna do that by putting x squared and negative x and 6x next to each other. And then I'm gonna combine y squared plus 4y next to each other. And then I bring negative 90 over the other side. Okay, and I'm prepared to do the completing the square in each part. I think we did that earlier at the beginning of the semester. All right, so what I'm going to do is take half of negative 6, which is 3. You square, I add 9. And then over here, you take half of this. It's 2, right? 2, and then square is 4. So you got to add 4 here. Since this is an equation, you add 9 and 4 on the left, you add 9 and 4 on the right. So plus 9 and plus 4. And after this step, we're going to rewrite that as x minus 3 quantity squared plus y plus 2 quantity squared equal. End up with 113, right? 113. Now, okay, from here, so I can see where's the center. Well, the center of the circle is at h is 3, so it'll be 3, right? X minus 3, and here y minus negative 2, so the k is negative 2. So that's the center, and the radius is the r squared is 113, so the r is root 113. All right. So that's how we determine the center and radius from the equations here. All right, so let's move on to the next type of conics called the parabola. Okay, now parabola is something we are familiar with, but we often focus on this form where the parabola either open up or open down. Now we're going to have a bit more general here. The parabola could open sideways to the right and to the left. That's one thing we're going to do. We also look at parabola from a different perspective, and again, that you might not know. Many students think a parabola is a U-shape, so basically anytime you have the U-shapes, it's gonna be a parabola, right? If you look at how about when you have y equal x to the fourth, you see if you grab this, it's actually it's like a U-shapes too, but it's flat. Or u equal y equal x to the 6, and then it's still, I mean, U-shape. But how do you differentiate between these and which one are considered to be a parabola? So here's the fact. A parabola is very special in the sense you're gonna start with a fixed point and a fixed line. Notice that for circle, we start with a fixed point, right? And then we collect other points that have the same distance to that fixed point. For the parabola, we will start with a fixed point in a fixed line, okay? Then I will collect all the points that have the same distance from the point, from this point and from this line. So for example, if you look at the midpoint here, so let's say look at this point, you see this point, the distance here to that, and that's the same. If I can find another point, say here, that distance and the distance to the line, oh, it has to be 90 degrees, okay, looking distance to the line. If this point has the same distance to the fixed point and to the fixed line, right, so that point is on the parabola. Or if you have another ones out here that has this distance and that distance the same, okay, if you have this the same, then that's on the I think I got muted for a few for minutes or two. All right, so let me say that again. If you have the line, the fixed line, the fixed point like this way, then your parabola will open to the right. This fixed point is called focus. This line is called the directrix line. Right? All right, so let's hand over to the formal definitions of our parabola. All right. So if you look at this parabola definition, A parabola is a set of all points x, y that are equidistant from a fixed line called the directrix. So this line here. And a fixed point called the focus. This point there. The midpoint between the focus and the directrix is the vertex. You see here, this point, midpoint between these two is in fact the vertex of the parabola. And the line passing through the focus and the vertex, this line here is the axis of the parabola, or the axis of symmetry. All right, we have learned that. But we haven't talked about the focus or the directrix line in algebra. Right, so again, look at the points should have some distance to the focus into the directrix. Now, the standard forms of the equations of the parabola with the vertex HK. So let's say the vertex here located at HK is given by the formula x minus h squared equal 4p times 1 minus k. This is where we have the vertical axis like this, where p is a directed distance from the focus to the vertex. Okay, the focus to the vertex. If we have the horizontal axis, so that is when you have, say, focus there, and then you have the directrix line like this. Then your parabola will open this way to the left. See that here we're going to have a horizontal axis of rotations. Okay. And then you would have this form, y minus k squared equal 4p times x minus h. Again, the vertex here, this point is still hk. Okay. Now again, p is the directed distance from vertex to focus. So in this scenario, your p is that distance, but it's directed distance. If the focus line on the left of this, your p will be negative. Your p could be positive or negative. Okay. So in this case, your p is positive. If it's open downward, the focus is below the vertex, and your p will be negative. Let's take a look at an example. Find the focus of the parabola given by y equal 1/2 minus x minus x squared. So if you're looking at this, it's not again belong to that form. If you look at this negative 1/2 x squared, all you know it's actually open downward, right? The leading coefficient is negative 1/2. But if you need to find the focus of the parabola, you need to put it into the standard form. Right, so the first thing I would do is to clear the fraction, right? I don't like the fraction, so times 2 on both sides. So you got 2y, and then that becomes 1, and minus 2x. 2 times 1/2 cancel, we got negative x squared. Now the next step is I think I have solutions out here already, but then the next step is I want to put it in one of these two forms. Because I know it's open downward, it's gonna be a vertical axis of symmetry, so it's gonna be this form. And to apply this, to write in this form, you need to have the x, you see the x quantity square on the left. So I decided to move the negative x squared to the left, become positive x squared. That becomes positive 2x. the 2y go to the right hand side, become negative 2y, because I want x on the left, y on the right. Now on the left hand side, to put it in the square binomial, you need to do the completing the square again. X squared plus 2x, so it take half of 2 is 1, you square it. So add 1 on the left and add 1 on the right. So add 1 on the left, you add 1 on the right, become a 2 minus 2y. Now the left hand side is ready to put in a square binomial, which is x plus 1 quantity squared. The right hand side, you just need to, again, to put it in that form, you need to have the y minus something. So you're going to take out negative 2, you factor negative 2, it becomes y. Take out negative 2 from here, become a negative 1. So we complete the form. Right, so we complete the form. Remember, we want to put it in x minus h squared equal 4p times y minus k. Now from here, you can identify what is what's h, right? So k is 1. So you have h is negative 1, because this is plus 1, right? X minus negative 1. So h is negative 1, and k is positive 1. And then remember we have a 4p. So 4p must equal negative 2, right? 4p is negative 2, and that means p is negative 2 over 4, or negative 1/2. See, from here, I can actually tell you the vertex and focus, even know how to graph it. You start with the vertex, right? The vertex is negative 1, 1. That's where the vertex at. So that's why I have negative 1, 1. So locate the vertex. When you locate the vertex using the p-values, that will tell you the locations of the focus. Again, the p is the directed distance from vertex to the focus. Since p is negative 1/2, meaning the focus will be lying half units below the vertex. So from here, you go half unit below. So if the vertex is negative 1, 1, the focus is negative 1, positive 1/2. So that's how I locate the focus. And I think that is what I'm asked for. Asked to find negative 1, 1/2. That is the focus. And then I can even sketch, I could do a quick sketch of the graph. You know, it's open downward, and that's how it looks like. Use the focus, negative 1, positive 1/2. Okay. Now, again, all you're going to do is you'll need to put it on one of these forms, and you'll locate the focus from there. Right? So that finished these sections now for the first part of 10.1.